So this is paper 2, which is what you all asked for. So what we need to be doing is making sure that if you're making flashcards, please make sure that you get down the keywords, because this is so important to making sure that you get all of the marks available to you. So anyway, let's get going. So the first question is, what is the precondition for binary search? The list has to be sorted. In a binary search, it has to be sorted. Linear search is the one where it starts at the very first item and works its way along. Essentially, with the linear search, this is quite difficult to get 4 marks on it. Exam technique, make sure you are, making 4 solid points to get that. So starts at the very first item, checks to see is the item you are looking for. If it isn't, it moves on to the next item in the list and checks this one. This will go through the whole list in order. That's a really important thing, because you can't just say like it goes through the whole list, because it's a little bit vague for the examiner, and either finds the item and outputs it, or gets to the end and says item not in list. Okay, that's probably a little bit more than you needed there, but that's all of the points that you'd need for that. Okay, so in this one here, we've got, so it says identify 2 variables in the function use words. So we've got number of words, which I'm going to make sure, because there aren't any spaces, don't give them any chances to not give you the marks for it. So make sure that no spaces, and also capital letters where they are. Contents. And then what it says here is you've got what's the difference between by val and by reference. So by val is where it makes a copy of the original value, and by reference is where it changes the original copy or original value. So it's to do with, if you do Python, you don't really have to do this that often, but in other programming languages you do. What happens is when you're passing the value, it potentially takes it from it either makes a copy of it and then uses that copy, which is by value. By reference, it's actually referencing the actual value, so it changes the original value. So later on, the values might be different based on the different, whether you use by value or by reference. Okay, so it says rewrite the function use words to use a while loop instead of a for loop. The function header and close have been written for you. Lovely. So what I'll do is I'll put that on the same page so that we can see it. And a lot of this is going to be actually quite similar in there. It's just we've got to be careful about how we're going to get the loop to execute. Put that T, there we go. Perfect. Okay, so let's have a look. We used by wrap. We've already done that, so we don't need to go on to that. So we're going to need contents, so we're going to put that in there. So contents, that's going to be exactly the same as before. Then this is where we're going to go while. Okay, so with this one here, we'll go count, because we'll probably have to create a count less than. In this one here, this is going to be number of words. So essentially what we're going to do is almost create a for loop out of this while loop. So we'll do number of words. And then the same part there is going to be, okay, so we can do contents equals contents plus words, square brackets, count, plus, and then we have to put the little speech marks at the end there, which that's going to be the same. Make sure you get the space in there as well. The for count, we are going to need it to go up though. So we are going to need to make it go count equals count plus 1. And I've just thought we have an initialized count, so we're going to need that as well. So we're going to do count equals 0. And then that will loop round, and this one, so that's all there. And then after everything that we've done this, we actually need to return content. So I'm just writing this in Python, so I don't need to put end while, but if you're writing it in pseudocode, you would do that. And you're just going to put return contents and make sure you've done that. Okay. Give one benefit and one drawback of declaring an array as a global variable instead of a local variable. So essentially with this, it's, so give me one global variable instead of a local variable. So you don't need to pass as a parameter, which is, if it's a global variable, you can use it in anywhere. So that can sometimes be a benefit, as you don't actually need to think about passing it as a parameter. It can cause more errors though. So it can cause errors in the program, and it's difficult to locate where the problem is if you have lots of global variables. So with this, if you use lots of global variables, it actually makes it very difficult to locate where all of the problems might be. If you use local variables, you know that everything is sort of built into each other, so that you know where in that particular function, if there's an error, it's going to be located within there. So it makes it easier for error checking. So yeah, that's what I'd go for that one. Okay. Describe one feature of an IDE that can be used to help write the program, and one feature that can be used to help test the program. So to help write, that would be things like syntax coloring, auto-completion. Syntax this will change color when you use certain keywords, and this will change color when you use certain keywords, and when it doesn't, this helps you to notice you may have made a syntax error. Testing is something like a variable watch window. You watch a variable throughout the whole program to make sure it runs as expected. Give two benefits of writing programs with reusable content. So it's going to speed up development time, as you don't need to spend time making it. If it's got reusable components in there, you also know that less error checking, as normally the program has been tested to make sure it works. So it kind of speeds up development time. It's going to be less error checking. So it's just going to generally be good in those two areas, and they work quite a lot. Those two answers. So speeds up development time, less error checking, can help out quite a lot in those ones. So speeds up development time, less error checking, more reusability in terms of that. Okay, so we have got we've got binary tree, and it says identify the root node in the binary tree. So the root node is the one at the top. It's kind of like the reverse of a tree, because a tree obviously grows from the ground up, but think of this one here, the top's there. So 2005 is going to be the one there. The leaf nodes are the ones on the end. So if you picked, so we can go for that one, 1952. And then we've got 2000 there as well. The other ones that you go for as well as 2100, 2560. It's just got to be at the end of a tree, essentially. So any of those ones. Okay, so 4 students have been added to the binary tree. Let's have a look at this one here. So we've got adding 1420. So it's, with binary trees, if it's less than, it goes to the left. If it's bigger than it, it goes to the right. So less than. And then you ask the same question again. So is that going to be less than? And they can only have 2 nodes. And then less than. So that's going to go here, which is going to be 14. Sorry, it's a little bit difficult to do it on here. So that's going to be 14 and 20. 2050, so bigger than. Less than, less than. So that's going to go it's going to go less than here. So that needs to go to the left of there. 2780, so it's going to go greater than, 780. And then finally we've got 2600, so greater than, and then we're going to go to here, which is then less than, so then it's actually going to go here. So I've brought this onto this page so that you can kind of see how it works. So essentially what the question's asking us to do is to traverse the binary search tree. And what we've got to do is we've got to compare breadth first and depth first. So I'm going to go through depth first because I think that's the more challenging one to understand. And it's a 9-mark question, this one. So the way in which we've got to think about this is it's the same pattern as we always do, which is like describe it, apply it, and then evaluate it at the end there. So do we understand what breadth first and depth first actually is? So what we can do is we can just quick description, talk about the nodes that are visited. As I said, the depth first one is a little bit more challenging. Depth first is this idea that what it does is it's kind of so the reason it's called that is because it starts at the bottom and kind of works its way along. So it's going to go 14, so it's going to go to this one, 1500, 1952, 2000, work its way around the outside. So it kind of does this tree first. So it starts here, works its way up, 1952, 2000, 1985, and then visits the top of that tree, which is 1920. Now here, so if you imagine, we've kind of done like this. 1985 there. Okay, this is the part where people really find it quite hard, and this is just practice, just going over lots of different examples of this. We then have to visit the bottom left of the next tree. Okay, so we've got this tree over here. So essentially what we want to do is we want to come down here. I mean, you want to start there. So we've visited all of those nodes, and then what we're going to do is we're going to come across here. So we're going to go up to here. So 2050, 2100. Okay, it's very tempting to cut across here, and then what you're going to do is visit the bottom of this, 2600, 2780, 2560, 2350, 2000 and 2005. As I said, I know that that's like, it looks crazy, but I would say the idea behind it is that we finish up on the root node. That's the last thing that we're going to do, and then the first thing that we've got to do is we go to the bottom left hand corner of the tree, go to the bottom left hand corner of the other tree, and you kind of work your way around the outside of it. So if we describe that, so we're going to say that depth first is where we start at the bottom left hand corner of the tree, of the left hand tree, and we work our way around the nodes until we finish at the root node at the end. And then probably what I would do to get the application marks is I would actually write down the nodes and the order which they're visited in. So 1420, 1500, 1952. So remember, it's working its way around the outside. 2000, 1985, 1920. And then we're going to jump to the bottom left of the right hand tree. So then we're going to go 2050, 2100, 2600, and then we'll go around the outside, 2780, 2560, 2350, because we're going around the outside, and then finally 2005. Okay, now breadth first, I generally think is a bit easier to understand in this one. So we've got breadth first is where you go through the tree in levels. You start at the root node, and then you go from the left hand side of each node of left hand side of the tree and work your way across. So that's, again, description, now application. So it starts at 2005 because that's the first node. So we kind of imagine this is like level 1. Then what you've got is level 2. So then what the next things that we're going to visit is going to be 1920, 2350. Then we've got level 3, which is going to be 1500, 1985, 2100, and you're just working from left to right. 2,560. Now, just be careful because, you know, in this case, it would have been better if what I'd done is I'd put the 1,420 at the same level as this, and also the 2,050, the 2,780, because it kind of is a little bit misleading because these ones here are all on the same level. Okay, so just make sure that you're working left to right, and then 2,600 should be the final one that we kind of go through on that one there. So 14 and 20, so it's all about the levels. 1952, 2000, put this over here, and then we've got 2050, 2,780, and then finally 2,600. Okay. Now, with the evaluative points, so obviously you get a lot of marks there for just going through and actually knowing what those ones are going to be there. And you've just got to have a couple of evaluative points which you can kind of talk about and maybe think to yourself about how, you know, a few things that you can say about them. I would say I'd maybe aim for at least 2. And then if you can go for more evaluative points after that. I would just have 2 solid points that I could make about both of them. And then if you can think about some more, get those in there. But remember, you're going to be having about, I would say, 10 minutes that you want to be spending on this. So if you think about it, if you're running way over, okay, just make 2 solid points. If you finish the paper, then go on with the rest of the paper. If you finish early, you can always come back and make some more points in this. So I'd just be going that breadth first, because it starts at the top, is more efficient trying to find the value near the top. And then the inverse is true for depth first. So depth first, because it starts at the bottom, it is much easier to find, or much quicker, I should say, rather than much quicker to find values that are near the bottom of the tree. Okay, so going on to the next one. A bubble sort will sort an array of 50 integer values into called numbers of array. State why integer values are stored in an array instead of separate variables. We can reference all 50 values using only one identifier. Okay, so that would be the thing about the main advantage of using arrays and lists. This is the bubble sort algorithm. So for here, it's going to be 50. Okay, and then we've got essentially a do until, which will always execute essentially once just to check it, and then it'll check the condition at the end, which if you're familiar with Python, this isn't something that we use in Python, but still, it's still going to be, you know, still something that you need to be familiar with. So it's almost like a back to front while loop. So the values that we're going to use are, we need to subtract 2 away from it on this one here. There are, I'll put out a video about all of the different algorithms on sorts searches. Also, we do have a little community, which is, which I'll put some links in the description as well, which we talk about all of these things, go through the algorithms, and essentially you can just make flashcards about this and just learn these, all of the big sorts that come up, quick sort, merge sorts. But yeah, I'll put a link about that. With this one here, this is going to be temp value, which is going to hold the value temporarily. And yes, sorry, I need to put a capital V there, so just be careful on like capitals and things like that, where it's up at the top there. So temp value is going to be a placeholder from when we're swapping things over in there. This one here is just obviously, so this is where we're comparing a value in a bubble sort with how the bubble sort works. So if the value, we want to swap this over. So if the one before it is greater than the one immediately after it, we need to swap this over. So we're going to say this is equal to the other one. And then what we're going to do is then you essentially just put the value in here, which is going to be temp value, which is just going to temporarily store it. There is actually ways in Python now where you can do that all in one go, which is kind of, because Python's been updated so you can swap it over on one line, which is quite easy to use, but you still need to know how all of this works, because as you can see that they do put pseudocode and things on in there. So those are all of the different values there. Okay, so we've got a section here which is going to be about merge sort. So it says show how merge sort will sort this section, going through this. Now, with this, it says show how a merge sort will sort this. I would probably put descriptions, and I would put the numbers in the order in which it goes. So with all of this, I would say split all of the items up into fours. So obviously you do split them up into fours, so it's going to be like 2, and this isn't anything to be doing with sorting them, because you have to get them individual to start with. So there's those over there, and I make a really clear distinction that they're together, and then these ones are together. Split into pairs. Just making sure it's really clear that you've got them all split up. So 2 and 12, 1, 9, then you've got 3 and 5, and then we've got 15 and 7. Okay, split into individual values. So then you've got 2, essentially 2, 12, 1, 9, 3, and 5, which is this is sometimes what people forget. Sorry, it's automatically putting those dots in there. You don't need to put those in there, but for some strange reason this is doing it. So you've got individual values. Then it's this idea of once they're all split up like that, then you need to sort them as you're pairing them back up. So pair and sort. So notice what I won't do is I won't pair them and then sort them. It's done automatically. So 2 and 12. 1 and 9, I mean, they're already kind of sorted because they're in the correct order. 1 and 9. 3 and 5. So it's only the last 2, which is actually, they'll get swapped around. So you'll see here, I don't pair them and then swap them. It's done simultaneously. And then let me just move this up so that you can see it. Pairs into fours. Sort, so then that's going to give you 1, 2, 9, 12, and then over here then what you've got is 3, 5, 7 and 15, which is kind of the same order, and then you just pair the fours up into 8s. Pair the 4s into 8s, which is now sorted. So then essentially it's just going to be a sorted list. So 1, 2, 3, 5, 7, 9, 12, 15. So it's just one of those ones where it's just be extra careful, make sure that you've got 8 numbers at the end. Yeah, that's all good. And just making sure that you're going through all of those different stages there with that. Okay, so on to the 12 marker, which is talking about each of the different algorithms in terms of insertion, bubble sort and merge sort. And we need to talk about the big O complexities and the suitability for each of these with sorting 10 values in there. So first thing, I'm just going to describe what each of these are. So bubble sort, take the item the left and compare it with the one next to it, and then swap if larger, or move on to the next item and repeat this process until the largest item at the end of first stage, and then goes back to the start and repeats process. So and then we've got insertion, is where we take the first item and place in new sorted list, and then repeat going through rest of list. Merge sort, where we split the list up and then pair up and sort as we are going through the list. So I'm just making sure and sort as we're going through the list. Okay, so I'm just describing, just making sure that they understand that I actually know what each of those sorts are. Then what I'm going to be doing is I'm going to be talking about how we are going to be, essentially with this one, we want to talk about the big O notations, which again is just, do you know what the big O notations for these are? You can obviously talk about the average big O notation, because obviously the best case scenario and worst case scenario. In this case, it isn't a very big list, so I would maybe be tempted to talk about the big O notation in terms of a best case for insertion and bubble sort, because there isn't many items. These aren't very good when there is a large amount of items, especially bubble sort is really bad. So I'd even make that point, and maybe you can make that later on, is the big O, which this is obviously the application part. Now, the big O notation, amount of searches in a best case scenario for insertion and bubble is going to be ON, which would fit this scenario because there are not many items in the list. Merge sort will always, well, not always, but on average, will have a n log, so O n log n big O notation. Okay, so you need to just specify to them, do you actually understand what the what the example of this is going to be and what the big O notation is? Okay, and then what I would start doing is, once I've applied it, so I get those application marks, what I'd then be doing is I'd be thinking to myself, okay, let's start making some evaluative points. So I'm just going to move this up, and I'd start talking about, you know, those things that I was saying earlier. So these aren't very big. This isn't, I should use proper English. This isn't a very big list, so may make sense to use insertion or bubble because it is a small list and they perform poorly on larger lists, but on smaller lists you do not need to use merge sort and use a lot of memory. Or merge will always use a large amount of memory for any search, and because this is a small list, it may be preferable to use insertion or bubble. Okay, so again, make your points. Because you've got 12 marks, I would say just you've got about over 10 minutes to see if you can answer these questions. If you need to come back and then make some more evaluative points in there, is because you may want to actually say, well, merge sort doesn't need absolutely excessive amounts of excessive amounts of memory because of all of the sort of like having, in really, really large lists, they would have huge amounts of memory, and this is a small list, so you actually maybe want to counter that point there. But I'd just be maybe thinking about, use the time available, and then don't run out of time on the rest of the paper, so then start going through that. So it may make more sense in, as I said, that you're talking about how the memory is there's going to be more memory usage in merge sort and in bubble rather than in bubble sort and insertion sort. So it might actually be better to use one of the other two because it's a smaller list, but you could then also make the point that actually it's not going to use huge amounts of memory. So you could talk about that, have more of a discussion, but remember, you've only got a certain amount of time that you can actually use on this. Okay, so with these ones here, let's just get some definitions down. So removal of unnecessary necessary parts to focus on what's important. Decomposition, breaking down into smaller problems. Give 3 things, the abstracted things. So it's like, what things can we take out which aren't super important? So you want to be able to focus on the speed, and actually maybe another thing is like focus on the weather conditions is probably what you want to be training people in those aircraft simulator to do. Removal of building and nature details, because obviously it's not super important. Like it's like really realistic. You maybe just need like a square block. The reasons for this is normally to protect the hardware. So it's like processor, limit the amount being used on processor, limit amount being used on memory. Okay, so in terms of caching, okay, so this is it's one of those ones because it does feel like this should be on paper 1, really. So it's just what with caching. Remember, it's we store frequently used instructions. So we store frequently used instructions. And data, so you don't to fetch it. So this could be, so then what I would do to get the application mark in this one is I'd probably talk about how, something that is going to be used often in this actual scenario. So you'll get 1 mark for just saying what it is, a 2nd mark for applying it. So this will be the weather, storing the weather conditions, or yeah, I mean you could say maybe like the level as well, so or the whatever it is, so the in the simulation storing the weather conditions in there. Okay, storing the weather conditions for that run through. Okay, so that's all good. Okay, so we've got so with this one here, we've got our graph, and we're going to say state one way. A directed graph is different to an undirected graph. State, this may seem quite obvious, but the edges can go both directions in a undirected graph. In a directed graph, they only go one way. State one way a graph data structure is different to a tree data structure. So a graph has cycles and a tree does not, which just essentially means that you can get round everywhere in a graph. It says give one reason why it's a visualization. So it's essentially it's this idea that you've got like symbols and edges are representing possible connections between nodes. Cool. Okay, so that's all good. Okay, so this one here, what we've got it's asking us to do Dijkstra's shortest path. I think it's asking us to show how Dijkstra's shortest path can go from node A to, let me put this on this. Okay, so on this question, what we're going to do is Dijkstra's shortest path algorithm, which is going to get us from A to H. So H. Okay, so we need to work out the shortest path of that, and we have to visit all nodes to do that. So what we're going to do is we're going to cross it out when we visited it, because we're going to start at A. And, you can write anything down that you need. I would, keep track of things that you're doing. So you can do A is equal to 0 because we haven't travelled anywhere and there's no previous node there. If it's helpful, as I say, cross it out. And then what you do is you put any nodes that are touching the edges. So from A, it's only B. So we're just going to put B is equal to 3. And that goes to the front of the priority queue. We do go through this quite a lot in the community, people, so you get a little group lesson and things like that where you can suggest what you need to do. So please do give us a message if that is something that you're interested in. I'll put a link in the description. So that's the first thing that we're going to do, and then we will put B, and we just need to make sure that we put the previous node, which is going to be A. put a capital A there. Now, the next thing is obviously we're going to go visit E and D from there. E is going to go to the front of the priority queue because it's a shorter path. So we're going to put in E is equal to 6 because it's 3 plus 3. And then D is going to be 10. We're then going to visit E because that is the next shortest path. The distance travelled to there is 6. And the previous node is going to be B from there. Now, in this, from here, then what we're going to do is we're going to visit, so we have to go all of the places from there. So C is going to be, C is equal to 3 plus 3 plus, so that's going to be 13, because it goes 3 plus 3 plus 7. F is going to be 9, so that actually jumps to the front of the priority queue because that's the shortest route. And then D is going to be in the middle of that, so that D equals to 10. So if it does help as well, you know, you might have a bit of crossings out and everything, but you need to be organising your priority queue like that. So then that's going to give you that. F is where we're going to visit next. So that's going to be 9. And the previous node that we visited from there was E. Okay. So we've got that in there. Then once we've got that, so we've got that in there like so. So that's all good. Then from E, we're just going to write down all of the different things that we've got coming from there. So the only other thing there is obviously G that we can bring in there, which is going to be 3 plus 3 plus. So it's going to be 9 and 7. So that's going to be 16. So G is going to be 16. I'd probably do, so obviously D is going to be 10. C is going to be 13. So it's going to be like that from there for us. So next thing that we're going to visit is D, which is going to be 10. And the previous node for that one there, if we cast our mind back to there, is going to be B. Now that later on, it's actually going to be, well, I'll talk about C in a second because it's actually going to be E is going to be the previous node, not D, but I'll talk about that in a sec. So that's going to be B. It's going to go from there. C, as you can see, C is actually the same distance going from there, but because we went this way first of going through E, even though that they're the same, E is going to be the previous node that we're going to visit on that one there. Now D, going from there, you can visit H from D, which is going to be 21. So we've got C is equal to 13 from there. G is equal to, and remember the previous node on that one, because even though that they're the same, you do need to put that your previous node was E because that was the first one that we actually got there too. H is going to be equal to 21, so we've got it like that. And then we're going to take out C from the front of the queue, so then that's going to be C. As I said, it doesn't make any difference really that about that one. You could, I mean, it's always good to check. So C is going to be 13, and as I said, the previous node for that one is going to be E. You can always run a little check, so you can do 3 plus 7 plus 3, but it's just going to be longer to go to E from there. That is going to be 20 as opposed to 6, so there's not going to be any point in replacing that. And then what we can do is we can run going from G, which is actually going to be shorter going to H. So G in there is going to be equal to, obviously, 16. We're not going to replace anything, but you can see 3 plus 3 plus 3 plus 7, 16, add the 3, that's actually going to be better, isn't it? So when we go there, so H is actually going to be equal to 19. So what we've got here is, and obviously if you're doing calculations like this, the examiner can clearly see that you've done Dijkstra's shortest path. You haven't just wrote essentially all of the correct answers in there. So then that's going to give us G, which the previous node of going to that one is going to be F, because that's going to be the shortest path going to there. And then H is going to be G. Now, you can if you want to. You can obviously put like 21, cross it out and put D in there. I have seen that on the mark scheme. But I think obviously that this demonstrates that you've done it, you kind of calculated it correctly as well. So I wouldn't be too worried about doing that. But if you can remember to do that, that's going to be absolutely fine. So it is actually 19 and the previous node is going to be G from that one there. Okay. Now you will notice at the bottom there, you've got the path which is going to be going there. So essentially what you have to do is you're just going to write the way in which you go around there. So it's just this. So it's going to be A B E F A B E F, and then it's going to be G H. So you're just going to go A B E F G H, which is going to be the shortest path to there. A B E F G H, which is that is the shortest path there because we don't need to go to D, and then the distance is going to be 19, so that's going to be the final part there. So just make sure that you write that up there. Okay. So the buzzwords that we're going to be using for these ones is a similarity is they both attempt to find shortest path. Difference is A star uses this thing called heuristics. Which is a best guess, so not all paths will be analysed. Statewide performance modelling is used to test the system. So what this is used to do is this is to test the system when under load, which just means it's tested when essentially we're actually putting values and trying to see if the system actually works when we're doing various different activities within it. Describe how a performance modelling can be used in the delivery system. So you can test large values and small values to see how the system behaves, and also increase the load to see how it behaves. So with performance modelling, it's all to do with how does the system actually behave under various different situations. So when it's got a large load or a small load, and those are the buzzwords that you need to be using. Okay, so in this one, what we've got here is we are going to be doing there's a card game, and you've got a deck of cards, gives two players 7 cards each. We take a turn to turn over a card. We're going to check if a valid move is a card of the same suit or the same number. And the winner is the first player to play all of their cards. And what it's asking is, as a component, which is a bit of a weird way to describe this, is checking for a valid move. Identify 3 other components. So it's just essentially saying, what are some of the features that we've got that are going to be in this game? So what functions, what different things are, what different things are we going to be having functions about in this game? So one of the ones that we're going to be doing is going to be giving players new cards, checking if a player has one, creating the deck. And this is just anything to do with the game. So this could be a variety of different things as well. So you could potentially have, giving the player a new card. It's just anything that you think that you would make a function about this. This one asks why check valid is a function and not a procedure. So this is because a function returns a value. That's all you need to say. A procedure does not, but I mean it's 1 mark, so that'll be fine. Okay. Now it says here that it's going to be using a selection construct to make decisions. Describe the decisions that will be made in check valid function and how these change the return values. Now in this one here, what we can't do is we can't just code it, because can you see it says describe? And I think what I've seen a few people do is what they'll do is they'll just write the code. This is something which you're not answering what the question's asking you to do. It's asking you to describe what's actually going on, and it's 3 marks, which again people will probably maybe get 1 or 2 of these, but trying to get all 3 is quite challenging. So it says if the player's card is the same suit. Okay, because that's obviously one of the conditions we're trying to see if the game, if we've actually done well in the game. That's one of the conditions of the game up here. If the player's card is of the is the same number, return true. And how these change the return value. So can you see that little bit at the end there where it says how these change the return value? So I actually need to add in there return true. And then obviously we've got to have the condition, which is just to check if it's not true. So if neither of these are true, return false. And what that's going to do is it's just essentially describing the situation. What's going to happen in this particular game page is we have got the cards are held in the 2D array cards. The first index stores the card number and the second index stores the suit, both as strings. Write pseudocode statement or program code to declare the array cards. Now, if you're using Python, this is pretty straightforward. All we've got to do is cards. Make sure you no capitals, don't do anything like that. Then it's just simply a case of square brackets, closing brackets on those, and then that's it. That'll give you 2 marks on there just to declare that. And just look in your own language if you're if you don't use Python, how to declare a blank two-dimensional array. You might have to, if it was in another language, you might have to say that it's, for example, a string. So just have a look at how you do that in your own language. Okay, it says, so question 7, a program uses the recursive function calculate. The function is written in pseudocode. Give the line number in the algorithm, calculate where the recursive call is made. So recursion is where the function calls itself. So can you see on line 5, that's where it calls itself because calculate is there, but it's called calculate, so that's how it does it. And then we've got state 2 features of a recursive algorithm. So there's 2 things. Well, there's more than 2, but there's the 2 main ones. Is a function that calls itself, and also it has a stopping condition. Now, a stopping condition is when, as the what's called the recursive function, it recursively calls, it needs to have an ability to be able to unwind, which the stopping point is going to be when it gets to 1 on this one. So I was thinking about how best to show you this one with the recursive function calls, because they are a little bit difficult to imagine if you're not super familiar with all of these. Let's talk through the function. So what calculate's going to do is it's going to add on to the number that we put in, and then what it's going to do is it's going to take 1 away from it until it gets to 1. So let's have a look at how it's going to do this then. So the number we're putting in there is 5. So the process of what's going to happen is 5 goes into this as a parameter. It isn't 1, so it goes to here. And then we have number, so 5 plus, and then another function call, which is going to be 5 minus 1, which is going to be 4. The confusing part of this is it doesn't actually add anything at this moment in time, which I think a lot of people get confused with. This actually goes into a stack. So what would actually happen here is then we would get another function call, which would be calculate 4, because 5 minus 1 is going to be 4. And then it just keeps repeating these processes until we get to the bottom, which is going to calculate 3, calculate 4, 2, calculate 1. Okay, so that's what's going to happen in each of those. Now the number part in here is just going to be 5, 4. Essentially, the number part is just asking like what number is going to be going in at each moment. Okay. Now, I'll just move that down because it's a little bit. Now, the complicated part is understanding with recursion about what is the order in which things happen. So essentially what we've got a situation of is the numbers are going to go like this. So the first one puts 5 onto the stack, right at the bottom of the stack. 4, 3, 2, and then we've got 1 up at the top. If I just line those up a little bit. Okay, so that's what it's going to look like. And in this process, it's going to go from the top. Now, if all of this is way too confusing, people, we do have a little community where you get access to a group lesson, online course, where you can ask me questions in the group lessons. And if you get really, really stuck on this, and we go through things like recursion all the time. So do reach out. If I'll put a link in the description if that's something that's going to be useful to you. It's pretty reasonably priced, and just could add a little bit extra to your revision. And you can email me anytime if you get signed up for that. But anyway, let's go through this. So what's then going to happen is we're going to start returning the values from the top. Okay. And progressively keep adding those values onto it. So the way in which this is going to work, to be fair, I don't think I'm really going to use this, but still, it's fine. The process is going to go like this. So we get to the stopping condition, which will then return 1. So we're at this part, the bottom part of it, which is calculate 1, and we return the value 1, because that's at the top of the stack. So that gets popped off. Okay, and then we go to the next value, which is going to be number, and then the function call, which we're now going to add calculate 2. Now, some people think that the value that will be returned is 2. This is not the case. It would actually be 3, because it's the value in the function call plus the number, which is going to be 3. And then we're going to go to the next part of it, which is calculate. So then we're going to go to calculate 3. So we take our number, 3, and then we're going to add that number to it, which is going to be 3 plus 3, which is 6. Then we take our next part, which is going to be calculate 4. So then we go 6 plus 4, which is going to be 10. And then finally we take 10 on, and we do 10 plus calculate 5, which is going to be 15. So the final value there is going to be 15 in there. And I think that's the most difficult part about learning about recursion, is that it kind of goes back to front in the way that you think it would go. We've got a last little question here. Give the pseudocode function call that would return 55. Now, what you can do in this case is that you can carry it on. So you could just keep carrying on the function calls like that. That would be one way, but just to save some time, what you can do is that you can go for this value here down here. So it says what would return 55. So the answer needs to be 55. I think I'd probably just carry it on. It's going to be the easiest way to do this. So obviously you just got 6, and then that would return. So 6 plus 15 is going to be 21, 7, 28, 8, 36, 9, 45, 10, 55. So your answer there is going to be 10. 10. Okay, so now we're on to section B, which starts off question 8. So we've got stack. One of the ADTs that we've done, abstract data types. And what it's saying is that it's got some values in there. It's got 100 potential things that can be in it, but this is just what's in it so far. It talks about pop, which is actually a bit of a gift that it's saying, like, tells us what pop does. It's saying it just removes an item from the stack. Remember, it's a LIFO data structure, so it's going to take it from the top of the stack, not the bottom. Queues, first in, first out. Stacks, last in, first out. And it's going to push it onto the top of the stack. So anyway, let's have a look at this. So it says shows the contents of the stack from here and after we've run all of these. So it's essentially just tracing through, can we do this? And I think this is a really good activity in terms of what, like with your stacks, going into the syllabus and looking at all of the different stacks that you have to learn for OCR, or even if you're not doing OCR and you're just doing this as a little bit of extra practice, look at your specification if it's AQA, look at that, and just be able to trace through what happens with the adding and deleting and removing items from there. So anyway, let's trace it through. So we've got, so pop, we're going to take 1 out because that's going to be at the back of the stack, and then we're also going to take out 23 because those two get popped off there. And then we're just going to push 3 on, which 3 is going to go to there, 6 is going to go onto there, 7 is going to go onto there. So for nice little 2 marks there, really, really easy. Pointer value is going to be, so we've also got to do that. I nearly missed the pointer value there actually. So the pointer value is then actually going to put to 6 because that's the next available value. So that would be after all of those, that would be there. So the pointer value here is points to next available space in the stack. And so yeah, just one of those really common questions that always comes up. Okay, so the next part is we're looking at OOP, and this is a super important part of being able to understand the different ADTs, the algorithms to add items to the ADT of choice, delete items from it, search for them and create them. And this is what we do in the community all the time, is we're looking at all of these common exam questions that come up. So if it's going to be useful for you and also helps to support the channel, please do check it out. I'll put a little description in there for you. But anyway, if you just want the free stuff, please do just carry on listening to this. So what we've got is we've got the pop method, and in this we've got to essentially remove an item from the back of the queue, the back of the stack in this case. So the first check that we need to do is make sure that the stack is not empty by checking if the pointer value is equal to 0, because that would be, if the pointer value is 0, that's saying that the next item, the next place that we can put it in is position 0, which would tell us there's nothing in there, so we can't remove anything from there. And in a second we're going to be looking at how a stack with a stack, because we're going to create the push one on the next question, is you have to do a check, which is it full? And because you can't add something to a full stack, so it's kind of thinking about that's the first thing that you got to do. Then the pointer values. Now, if we are actually removing an item from there, we need to change the pointer value back by -1. And then what we're going to do is we're actually going to return the value, which is going to be the pointer value in there, because that's the thing that we actually want to take out of there. And then finally, we're just going to return the value. So that's just going to be the thing up there. So it's going to be, make sure that you spell it exactly the same with the capital letters. And then that is going to be our pop function. The next part is we need to do the push algorithm. Now, I've brought this page onto here because it gives us all of the names of the different attributes and the different methods that we need to be using. And this is really important in this section, is that you have to use these exactly the same. So always make sure that you're referring to this when you're using, creating different methods and when you're in the OOP section, because they're telling us what they want us to use here. So for the push function, essentially what we're going to do is this is where we add an item to the back of the stack, and we need to run a check first to make sure that it's not full. And it's also asking us to make sure that we return true. Essentially what we're going to do is we're going to look at the pointer value. We're going to add the item to the stack, and then we increase the pointer value by 1, and that's the process. And this is, we're always going through and checking all of these different algorithms to make sure that we know all of these ones about the different ADTs, how to add a value, how to not do that. So what we've got here is, so it says here we've got push and value. So make sure that we put that exactly the same in there. I'm just going to be using Python in this case, but obviously use your programming language which is relevant to you, if that's the case. And we're going to do our first check, which is going to be if pointer value is less than 100, What we're then going to do is we're going to do stack array, which is going to be the array, which is actually going to be the stack and the name of it, which is, we can see here, so stack array. And then what we're going to do is we're going to put square brackets, pointer value in there, just like so. And we need to go equals value. Okay, so we take the parameter here and we're going to store that in the stack. That's going to give us that, and that's going to put the value in there. The next thing that we need to do, as I was saying earlier, is we need to increase the pointer value to point to the next available location. So we do pointer value equals pointer value plus 1. And then we're going to return, as it says, we need to return true if we've done it correctly. Else, what we're going to do is we're going to put return false, because that means that we haven't made an acceptable. This just means that we've not added an item to the stack because the pointer value was 100 or greater. I mean, it will always just be 100 because that's the maximum that it can be. The final little bit there is where we've got is the main program needs to initialize a new object of type stack with and we're going to call it the identifier with math stack. Write the pseudocode or program code to declare the object. So the class is called this to instantiate the object. We do maths stack, and then it equals, and then in Python, this is how you do it, is you just put the class name, brackets like that, and then that is the object instantiated. So just make sure that you put the spelling all correct. So yeah, all of those different features in there. So the next thing is it says that we need to do a fill in the blank task, which is the main program needs to take numbers as input from the user, push them onto the stack, math stack, until the stack is full, output an appropriate message if it's full, and then we're just going to complete this algorithm. So return value equals true, while return value equals true. What we're going to do is we're going to return value equals math stack dot and then push. So it's going to push that on and it's going to take the input from the user. If the return value at any point equals false, then what we're going to do is print stack is full, because that will have, in the other functions that we've done, what that'll do is it'll change that to false because we cannot add any more items to it. So that's how we finish that little part there. I just put this on a new page because I thought it might be a bit better. But anyway, so the main program also needs to remove one item from the stack at a time and add this to a total. Output the total every time an item is removed. Stop removing items while either the stack is empty or 20 items have been removed. Write the pseudocode to do this. Okay, so essentially we're going to need a while loop to do this, and we're going to need to initialize the total, the quantity, because that will be checking if it's over 0, and then that will be all good. So then we're going to have our while loop, which is going to be checking, which is if the return value is going to is not, while the return value is not equal to -1 and quantity is less than 20, what we're going to do is we'll return value equals, and then it's math stack dot pop. So that's going to get the item out of the front of the queue. So that's going to get the back of the stack, and then what we're going to do is then we just need to add that. So we're going to go if return value is not equal to -1, I'm going to do add 1 to our quantity equals quantity plus 1. And then what we need to do is we need to add this to the total. So total equals total plus return value. And it also asks us to output this as well. So we're going to go print total. And then that's everything all done that it's asked us to do there. So for this question, it's just talking about queues and describe how an array can be used for a queue. So a queue is a FIFO data structure that uses tail and head pointers. When you increase the, enqueue, we need to use the key term. So enqueuing is where you add items, dequeuing is where you remove items from the queue. The way that enqueue works is you always add, so it's a first in, first out data structure, which essentially means that the first item that's in there, that is the first item that will be removed. So when you enqueue, which is adding an item to it, you decrease the tail pointer, and then just the inverse is true for when you dequeue. When you dequeue, you increase the head pointer. Question then, people, which is so we've got discussed the use of OOP and procedural programming to create and manipulate the queue data structures. So in this one here, what it's talking about is the features of OOP, the features of procedural programming, the benefits of using OOP over procedural. So go with the way that I always say, which is just say what you know, try and apply it to the problem, and then if you can make any evaluative points about that. Sometimes what that will do is that will jog your memory if you can't think of any evaluative points, and you can kind of apply that to the situation, which then is going to get you up the mark bands and hopefully those into the sort of 7 to 9 range, which is obviously what you want. So let's just talk about what OOP is. OOP is where you can make a class which is a blueprint for your objects, and then you can instantiate, which is just instantiate as many objects from this code as you want. You then can attach methods such as, attach methods which will alter the attributes, which will be private, to help with data protection. And procedural is where the code is executed one line after each other and is a more basic form of programming. Okay, so we're outlining what it is, applying it to the scenario now. With OOP, this will mean we can make multiple queue objects, I should say, related to the question, queue objects, with not a lot of extra code. Procedural, I'll have to make much more code to do the same task in comparison to OOP. Also, with encapsulation, so try and use as many of those big buzzwords that we know about OOP. I will not be able to edit the enqueue and dequeue methods. No, that's not what I want to say. I'll not be able to edit the attributes such as size and pointers. So again, show off what you know. Pointers without using the methods such as enqueue and dequeue. In procedural, I could quite easily edit variables and I don't know if I like that. I could more easily edit values than in OOP. Okay, so I've applied it to the prop. So I've stated my points and then I've applied it OOP. Okay, so I've made my points. Now let's make it a little bit more evaluative. I always think with the evaluation that you do kind of end up making a couple of evaluative points anyway, but let's really hammer it home just to get into that top mark band. So OP is great for having less errors, as if you had to make multiple objects. It's not a lot of extra code. Multiple objects. Try and relate it a bit more to the question. So multiple queue objects is what I'm going to say. There's not a lot of extra code to instantiate. But with procedural, there's a high likelihood. Or is it? And there's with procedural, I'd have to so many more lines of code. This increases the chance I get an error in my queue. Also, in terms of reusability, this will be much easier as the what's the word I'm looking for? The standard of encapsulation will be used, keeping all attributes private. In procedural, this will not be the case. And as I said, if you can think of some more points, potentially what you could be saying as well is it's just less code. It's more so it's more elegant. There's maybe a thing that you could be saying. Getting as many of those evaluative points as you can. Anyway, that is everything, people. I hope that was useful, and I'll keep trying to bring out more and more of these. Thank you very much for listening.